going to kick it over to Brynn right away. Certainly an expert, and he'll give you a little detail on his background in HVACs, heating, cooling, and he's fresh off a long week of training, so he's perfectly primed to teach us a bit today. So, Brynn, I'll pass it your way.
Thank you. Thank you. Well, good evening, everybody. Welcome to our webinar tonight. This is Home Cooling Best Practices, and my name is Brynn Cooksey, and we'll get going. All right. My background, uh, I own two businesses in the industry. One is a home performance contracting business. We're headquartered in Southeast Michigan, but we have another branch that's growing in the Metro Atlanta, Georgia area. So that's Air Doctors Home Performance, and in that business, what we do, we perform energy audits. We do the repairs, the whole house, the building shell, HVAC, electrical, and then we test out to ensure that we hit our mark. And where I spend most of my time is another business that we own. It's called HVAC, also known as the building scientist. And what we do in this business, we teach other contractors about the benefits of home performance. If you want to reach out to me on social media, that's a QR code to our LinkedIn profile. I've been in the industry about 24 years. In this presentation, we're going to talk about cooling systems and talk about the building science behind it. We're going to identify some of the biggest causes of poor cooling efficiency and things that contribute to customer discomfort. We're going to talk about practical cooling improvements and HVAC systems, and then we're going to talk about how to reduce energy use and improve comfort. Now, when we look at the cooling system, measures kind of include one, replacing the equipment or making the equipment more energy efficient, but also, is there things that you can do to reduce the load or the amount of BTUs that's necessary? And we'll talk about that at length in this presentation. One of those things could be, could your home benefit from some type of solar film? All right? I mean, many people don't think about that, but that's a way to reduce the amount of heat energy that's coming into the house. What about air sealing and insulating ducts in an unconditioned space, or awnings or shutters? We'll talk about those things too and how they impact the cooling load. Honorable mentions, we can't forget about the cleaning tunes and how they affect the system, and then other general waste heat reduction techniques. Now, when we talk about the air conditioning system, it's important to note that when we talk about the air conditioning system, we're talking about the refrigeration cycle. And kind of a brief overview, what this refrigeration cycle is a system of components that is going to transfer heat from one area that we don't want it, say our house in the summertime, to an area that's unobjectionable. If you have let's say, a furnace in an air conditioning system or air handler in an air conditioning system, depending on where you live, we're going to absorb heat in our evaporator that's usually on top of our furnace or air conditioner. That's going to go and get pumped through our compressor. Then it's going to get pumped outside to our outdoor unit or condenser. And maybe if you've experienced this. Have you on a hot summer day ever walk by your outdoor unit and maybe put your hand over top of the fan as it was discharging air? And if you think about that air was really warm. And if it was warm, that's an indication of the heat energy being rejected out of your house. So this is a cycle that does that. And when it rejects the heat energy out of your house, it cools the refrigerant to prepare it for reuse inside your system. Now, this system is consuming electricity, and it's one of the biggest loads. In fact, it is the biggest load from a consumption standpoint or raw power that's inside your house. So it's imperative that it operates correctly. Now, when we talk about air conditioning systems, we need to compare them apples to apples. And there's a couple ratings out there, and we'll describe them here. When we talk about an air conditioning system, let's think about a regular central air conditioning system. One of the ratings that we often hear is a SEER, SEER, and that is the rating of air conditioning systems, so you can make a comparison. What SEER stands for is Seasonal Energy Efficiency Ratio. And what it means is how much air conditioning or how much heat removal did I have from that structure compared to the electrical consumption that was put into the compressor or the actual air conditioning system. And the way it works, the higher the SEER, the better. If I have a 13 SEER is good, a 21 SEER is better. What's happened recently, because air conditioning systems were often connected to undersized duct systems, and those duct systems, in many cases, they were not sealed and insulated properly if they needed to be. And what happens, the nominal rating that you see on this tag here, all right, the equipment didn't perform that way. And as a result, when you reconcile the nominal rating versus the performance, there was also always a big disconnect. So back in 2023, the U.S. Department of Energy mandated a new designation, and they call that SEER 2. And what SEER 2 means is now we're going to have air conditioner ratings that account for the losses that occur with the average American home that this system is going to go into. So as a result, you have more accurate real world testing that's going to be closer to the nominal rating. So as a result, air conditioners manufactured after 2023 are going to be rated as SEER 2. If you have an air conditioner, a window air conditioner, that's a little bit different rating. We're going to use EAR, or energy efficiency ratio. This is an instantaneous measurement. It still compares the amount of energy you consume versus the BTUs that are removed from a structure. However, the SEER for central units, they take into account the energy consumption over a season, where for a window air conditioner, they're going to use instantaneous measurements. So pretty similar measurement, but for different purposes. And before we move on, this energy guy sticker, I'm sure you've probably seen that before and if you're out and about shopping with your family. This energy guy sticker is a requirement, and what it does, it gives you information so you can compare two models apples to apples, and that way you can kind of get a understanding of the capabilities of this particular device, and also an estimated yearly cost that it will take to operate this piece of equipment. Now, when we talk about cooling systems, it's pretty shocking that a lot of the systems, especially in my career, I've measured thousands of systems and they all underperformed without modifications. So when you have high efficiency equipment, it doesn't necessarily mean that it's high performance. And there's some factors that are going to reduce that performance. And we're going to talk about those. All right. They could be poor installation practices. All right. Was the equipment installed to manufacturer specs? It could be the distribution system connected to the air conditioning system that you can have some issues. In many cases, if the ducts are in an unconditioned space, are they insulated? Then proper refrigerant charge, and then a proper system airflow. All things that kind of take the edge off of the air conditioner performing as it should. Let's look at some common issues. All right, so these statistics are coming from the Department of Energy. And one eye-opening statistic is the refrigerant charge. And it says half of the systems in the United States are improperly charged with refrigerant. And you may be thinking to yourself, how is that the case? How is that possible? Well, when we take a regular air conditioning unit for residents, and that equipment is designed, and we're talking single stage equipment that turns on and off. That equipment, when it's shipped, is shipped with a certain amount of refrigerant for a certain length of line set. And many manufacturers use 15 feet, some use 25. Well, the way it works, and we use the 15-foot example, if I put in an air conditioner and the line set or piping between indoor and outdoor exceeds 15 feet, then the technician is supposed to add refrigerant because it's the line set length exceeded what the manufacturer allotted for. And the vice versa, the reverse is also true. If I had less than 15 feet, I was supposed to trim the charge or remove refrigerant. And oftentimes, that process just doesn't take place. So this is pretty eye-opening information here. And just by the refrigerant charge being slightly off for these machines or systems, you can have some significant energy penalties either way if it's undercharged or overcharged. So really eye-opening. Here's another statistic, all right? Improper airflow. 70% of the HVAC systems in the United States have improper airflow. All right, that's eye-opening. All right, we'll talk about that in depth. All right, here's some of the causes. When we talk about the refrigerant charge issue, that's technician influence, some improper handling techniques, maybe some non-compliance with reading the instructions or lack of training. When we look at airflow, it can be a number of things. It can be neglect from the customer or end user. It can be improper system design, or a load calculation and duct assessment wasn't done. We're going to talk about those two. Now, let's talk about the heating and cooling loads. In my uh, training business specifically, this is one of our biggest things that we're trying to train contractors to do. Is the air conditioner sized correctly? All right, that's a really big question. And oftentimes, unfortunately, it's not. There's a process called a heating and cooling load calculation where you calculate the amount of BTUs the structure is going to gain, and you're going to size the air conditioner to remove those BTUs. All right, it's a calculation, engineering specific, and it's often not done in many cases. And there's a number of reasons why. Some contractors feel that they may benefit from a square footage per ton rule, which really baseless. It's not information to support that. Well, the load count, when done properly, ensures that the customer is going to be comfortable, the equipment is sized properly, and there's not any waste or poor energy consumption. Now, when we talk about the heating load is the amount of energy we're going to need to offset the temperature difference when it's cold outside. All right, we're going to calculate those BTUs. All right, the big drivers for the heating load is insulation that you have inside your structure, and then how leaky the house is. When we look at the heating specific, the design stake points that we work with is 70 degrees indoors. And the outdoor temperature that we're going to compare it to is going to be a sustained average. We're talking about 99% of the time, we're going to be at this temperature and above. And that data is collected over years. And we need to size our equipment appropriately because these are the things that's going to happen. It's going to be less efficient. We're going to get breakdowns and we're going to get excessive energy consumption. So that's on the heating side. When we transition into the cooling side, there is more data that we need to get. So a contractor that is looking at a home to apply air conditioning, they need to be there for a while and get a lot of information, such as how many people are in a house. All right. If I don't know the occupant uh, range in a house or the number of occupants that I'm going to expect, I truly can't design an air conditioner. I need to know how many people we're going to expect. When people do this or contractors do this, they're typically looking at what the house is designed for. And we typically use a bedroom plus one. So if you have a four-bedroom house, we're going to design for five people. The houses were designed for a nuclear family with two people occupying the master bedroom. What about pets and plants and lighting and appliances? All these things are factors that calculate the amount of BTUs that are going to be inside that structure, in addition to the insulation levels, air leakage, and how much solar energy that structure is going to get. All right, so there are no rules of thumb. We have to account for all these variables to properly size an air conditioner. And oftentimes, again, I'm afraid to say it is not done appropriately across the country. All right. When we look at the cooling load, we're generally going to design for a 75-degree temperature indoors, and we're going to design based on outdoor temperature, which is going to be the temperature that we need to reject the heat to, and that's going to vary based on your climate and region across the country. And then we're going to design for an outdoor wet bulb or coincident wet bulb temperature, which is an expression of humidity. All right, so the air conditioner not only does it remove BTUs from the structure, it also reduces moisture inside the air. It reduces that relative humidity because relative humidity can impact our comfort and also can be an indoor air quality issue. Again, we want to avoid oversizing. If we do, it's going to be less efficient. It's going to short cycle and it's going to leave excessive moisture inside the structure and you're going to have excessive energy consumption. Let's drill in on two important keys here on this slide. Let's talk about excessive moisture. Have you ever felt cool and clammy? All right. If you can recall that experience, that was a situation where the temperature was reduced, but the water vapor wasn't pulled out of the air. This is a classic symptom of an oversized air conditioner. And in certain cases, if it's really bad, it can start to promote biological growth. What about more breakdowns? Furnaces, air conditioners, they operate kind of like vehicles do, and they get their best efficiency while they're running. If they start and stop, you're going to get severe breakdowns. And quite often, when I'm in my in-person class, we to use this slide and to hit the point home, I ask students, what's better for your vehicle, city miles or highway miles? And they'll say, well, highway. And then I'll ask why. And the reason why, you're going to, you have the proper operating temperatures, less wear and tear on your brakes. It's overall better for your fuel efficiency. Air conditioning and furnaces run that same way. You're going to get better efficiency when the equipment is running. If it frequently starts and stops, you're going to have a lot of issues. Other things to look at when we talk about cooling systems specifically, was there a tent for shading? All right. Some architects design homes where they'll have a tree to provide shading, which reduces the load. The biggest driver of the air conditioner is the solar load. So if I have some type of natural shading, that can help to reduce the load. Other forms of shading include interior shades or drapes, exterior, which can be shutters or awnings, or like we talked about, landscaping elements can also provide some shading to reduce the amount of BTUs that the structure has to remove. All right. Now, in a perfect world, this is the design process that a contractor should have followed. All right. Looking from left to right, we have our residential load calc. So this is ACA Manual J. All right, this is a residential heat loss heat gain calculation. It's a pretty thick book, and it has the procedures for to appropriately identify the structure, the materials, the insulation, the air leakage, the amount of people inside, all the details to calculate BTUs and the size air conditioners to figure out what the demand or load is. Once we calculate the BTUs, we then have to follow Manual S. Manual S is selection. So we take those BTUs and we find the equipment that can cover those BTUs at our design temperature so that we can appropriately deliver that energy into the space. Now, no good system is going to do everything by itself. I have to have a distribution system to take the energy out of the equipment and deliver it into the space. All right, that's where Manual D comes in. Manual D stands for ducts. Manual D duct design. Now, this is another problem in this country. Oftentimes, ducts are too small and they don't deliver the energy that the appliances are creating, and as a result, I don't get the appropriate rating. So my nominal rating is this. However, my performance rating is this, just because I have a distribution system that can't carry the energy into the home. All right. So this is the 1, 2, 3 step minimum contractor should be following Manual J, S, and D. Now, we talked about heat gain. All right. So I want you to think about heat either coming into the building shell or envelope or heat being generated inside. And remember, an air conditioner has two functions. It's going to reduce the temperature and also remove the moisture to make sure that we're comfortable. All right. Let's talk about some solar film. If you think about the track of the sun, and I have a slide here coming up, solar energy is the number one driver of air conditioning load. And to increase the efficiency of an air conditioner or your cooling system, either I have to make the equipment more efficient or I can reduce the BTUs that are required, and therefore I have a smaller air conditioner that's going to use less energy. With that being said, I can apply a solar film, all right, some type of window tinting, and I can apply that film on my south, west, and east facing windows. The sun rises in the east and sets in the west. So in the east, in the morning time, that part of the home is going to get all the solar load. When I look at the south side, it's going to get bombarded all day, and the west side is going to get it in the afternoon. You can reduce some significant BTUs by using some type of solar film. Okay. Here's the sun's path. Rises in the east and sets in the west. And you see how on the north side is shaded here. All right. In both cases, this is the summer. See how the sun is high in the sky? And this is the winter. It's lower in the sky and I have deeper shadows. If I put my air conditioner on the north, I can also impact its operation by it running cooler. Or I even have troubleshooted problems where customers were warm in the morning and comfortable in the afternoon, or vice versa. And as a result, it was because there wasn't enough CFM or airflow in those peak times of the day that made them uncomfortable. So something, if you're planning new construction, something to keep in mind, or if you're troubleshooting, it could be as simple as there's not enough airflow to those rooms once they're getting the sun, right? It can be as simple as that. Right? You all are a solar organization, so you know all about pathfinders. There are ways to help indicate your solar load. A lot of times now, there's all kinds of information on Google to help you find that. But what I want to show your attention to, anytime I can put up some type of tent or reflection or blockage of the UV radiation from the sun, and I cast the shadow here, I reduce BTUs from going into the structure. We talked about the solar film. It can cause some significant improvements. You can purchase it, you can apply it to your windows. You can purchase windows with it. However, if you have some type of film to reduce that solar energy that's coming in, or more appropriately, infrared energy, you can really save some significant BTUs from a load calculation standpoint. All right. So now let's talk about the ducts. Did you know that if the ducts were not sized properly, if they were leaking and they were not insulated, they can impact your air conditioner's operation? All right, so what you see here is two technicians, and what they're doing what's called a pressure pan test. And if you can imagine this house, the ducts are in the attic. All right. In the summertime, the attic is hot. And if the ducts are not insulated, the BTUs from the attic are going into the duct and they're going to reduce the capacity and effectiveness of your air conditioner. Really important. As a minimum, we like to insulate our ducts in the Midwest to R8. Another thing that they're doing with this pressure pan test, and this is with the assistance of a blower door, if the ducts are leaking, they can bring in that hot attic air into the space that the air conditioner then has to remove. So making sure your ducts are sized appropriately, sealed, and insulated if in an unconditioned space is really important for air conditioning performance. Here's what a duct looks like. This is in an unconditioned space. Anytime the ducts are in an unconditioned space, I need to insulate them. So the appropriate way to insulate them is to pull an insulation back and apply some type of solution, whether it be mastic and approved UL 181 air connector tape. And when you apply that, you're going to apply it, let it dry, and then pull the insulation back over. And here's a picture of mastic. All right, you'll notice it's mastic here. A good effective job when you are using mastic is to have it apply about the width of a nickel. If you were to take a nickel and lay it flat on the table, you want it about that eighth of an inch thick, all right, just so you can make sure that you got complete coverage. And notice again, the insulation is pulled back. Once this mastic dries, I want to pull that insulation back over. There are other solutions like AeroSeal where you can seal the ducts from the inside. Is outside the context of this conversation, but there's other alternatives. However, the key point, ducts need to be sealed. They need to be properly sized first. They need to be sealed and then insulated if in an unconditioned space. Another key point with ducts are the fittings. All right. These are the fittings and elbows. If you've ever bought an HVAC airflow elbow, the elbow can be repositioned. So it comes as a 90-degree angle, but I can reposition these swivel points on here called gores to accommodate different angles. Those are never leaked tight, and as a result, they need to be sealed as well. So don't forget your elbows. Other things to consider, there is a study from the NACA Association, National Air Duct Cleaners Association, and they basically, in a nutshell, in that study, they identified that if ducts are clean, it can increase the performance and reduce some indoor air quality issues. So you might want to get some consideration of cleaning the ducts. All right, the ducts, as you see here, this is dirt and debris, and it will cause a drag on the airflow as it's going through the duct system. So as a result, maybe contemplate cleaning the ducts, and then once they're clean, then make sure that they're appropriately sealed. So this is a before and after of the ducts being cleaned and then sealed. Okay. In the Midwest, we often use cavities for ducting. All right. Again, if accessible, they need to be cleaned and sealed as well. Another thing many people don't realize is that you can use reflective coatings or surfaces to reduce the amount of heat that's going to be transferred into a structure. Again, the solar, the sun load, infrared energy from the sun has the biggest impact on your load. It's by far, it's about 20% of the total air conditioning load. And if I can reflect that solar energy back out into the atmosphere, that can do some substantial BTU reduction. So much so, some studies have shown up to 60% by having some type of reflective roof. Here's an example. On the picture on the left, you see a brick wall, and we have a painted, regular paint, uh, painted strip here. And with this strip, you're seeing what's occurring here. And on the right, we have a comparable thermal image. All right, my thermal imaging camera can take a real picture and a thermal imaging picture at the same time, and you can overlay them on top of each other. Look on the right picture, though. Look at the temperature difference between the strip of painted white paint and the rest of the brick. And it's about a 5 to 10 degree difference. And you can substantially see blue is cooler, that this strip is quite a bit cooler compared to the brick. All right, that white strip has a reflective capability to keep that surface cool. So if you do this to some type of roof or structure, it's a common building construction practice to do it in parts of the country like the southwest and west areas or south of the country. Oftentimes, you might see them have lighter color roofs, and what that is, that's an indication that they're trying to reflect more solar heat back into the atmosphere. All right, now let's talk about the equipment. All right, so you can reduce the load. Um, we talked about you need to properly size it, you need to have the ducts. All right, you need to insulate the ducts, and they need to be sealed. All right, now sooner or later we got to get to the equipment. Now the equipment is there. You don't have any control of the other design aspects. You need at least need to make sure that the equipment is operating correctly. All right, so you want to do a tune-up. All right, when you do a tune-up, you want to clean and tune the air conditioning system. But what does that involve? You're going to remove obstructions. This is an outdoor unit. This is a condenser, and if you can picture it in your mind's eye, air is going to flow through that atmospheric air, ambient air, and it's cooler than that coil. And remember when we talked about the onset of the presentation, how if you put your hand across this and it's going to be warmer to the touch? Well, the air that goes across that coil is what is cooling the refrigerant to prepare it for reuse so it can go back inside and do its job. Well, if that coil is dirty, it increases the operating temperatures and pressure, which is a direct correlation to energy consumption. It's gonna consume more kW per H, because it can't reject the heat. So it's going to run harder to do the same job. So we need to ensure that these are clean. In the indoor, we need to make sure that the evaporator is clean. Cleaning and replacing filters, oftentimes neglected. We need to make sure those are clean. We're going to talk about the coolant line, and we're also going to talk about if the unit is not level, what can happen. It can cause the oil not to properly lubricate the compressor inside and cause some issues. Then lastly, well not lastly, we got one more point, the refrigerant charge, right? We kind of expressed on the onset of the presentation that a significant portion of the systems out there, over half, are not charged properly with refrigerant. All right, doing a proper tune-up, a certified refrigerant handling technician as EPA licensed will evaluate that to determine if that system needs to be trimmed, either adding refrigerant or removing it. Now, if you do replace an air conditioner, you must have a load calculation done so that it can be sized appropriately to manage the BTUs but not cause a negative effect on your utility bill. All right, now we're going to teach you the secret handshake of air conditioners. There's two ratings for air conditioners. One is amount of BTUs per hour, and then there's a probably a more slang term called tons. Okay. All right. When we calculate the loads, it gives us the BTU per hours, but there is a term that we need to know about called tons. All right. There's 12,000 BTUs per ton. And the way the systems work, there's a 1 ton, ton and a half, 2 ton, two and a half. 3 ton, 3.5, 4, and 5. Those are the typical residential sizes. Some manufacturers make a 6 and 7, but 1 through 4 with half sizes and then 5 tons. Well, there's 12,000 BTUs per ton. All right. So what happens when we need to know about the ratings? We need to look at the manufacturer's model number. All right. So here's the trick. When we look at the model number, we're looking for a multiple of 12. Okay. And you see, I have two, I'll say, potential candidates here. I have a 3.0 and a 2.4. Usually, for older type of equipment, the last set of two numbers that are divisible by 12 is the nominal rating in BTUs, and then we can convert that to tons. All right, so the last set of two numbers here is 24. 24 divided by 12,000 gives me 2 tons. So this is a nominally rated 2-ton air conditioning system. All right, the styles of air conditioners. So I can have a package where everything is in one enclosure, or I can have a split. A split means three pieces. I can have a ducted split or a mini split. Now, here's how the air side and the refrigeration side works. All right, in your house, let's imagine you have your thermostat set at 75 degrees. And I'm going to pull air into this return at 75 degrees. And it's going to come down, this air, and it's going to come into my blower. And my furnace air handler is going to pressurize that air and push it up through this coil. Okay, this evaporator coil. This evaporator coil is receiving refrigerant from this outdoor unit. And when it gets to this coil, it's about 55 degrees Fahrenheit. Or I'm sorry, about 45 degrees Fahrenheit. That 75-degree air, when it goes into that 45-degree coil, is going to discharge about 55-degree air. That air is going to leave and go into your space. It's going to blend with the room air that's there. And once it blends appropriately and is designed correctly, you shouldn't notice that the system is on. You should feel comfortable, which means you didn't notice your surroundings. All right. Once that heat energy gets inside the coil, the refrigerant is going to take that heat energy. It is now warmer than 45 degrees, and it's going to get pumped out to the outdoor unit. An outdoor unit has two parts. It has a compressor, which is nothing more than a vapor pump, and then it has a fan that is going to pull air from the sides and reject that heat energy that we just picked in from the house. So specifically, the heat energy that if you put your hand across the outdoor coil, that is the heat energy from your house. When you reject that heat energy, the refrigerant cools down and is going to come back and restart the cycle. So the typical air conditioning application, you have a airflow cycle that's circulating the air, the warmer air to cool it off, and then I'm circulating the refrigerant to uh, to absorb the heat and to come out and throw it outside. And once it cools off, it's going to bring it back in and start the process. And both of these processes are going to run over and over and over again until the thermostat tells it to stop. All right, cleaning the indoor coil. This one is a little bit tougher. This is the indoor coil, and this all depends on if you have access or not. All right, what can happen if I don't change my air filter, which isn't shown here, and the air starts to bypass and it can contaminate this blower wheel and also this coil. So part of the tune-up would be to clean those coils if I have access to it. All right, so to do that, I want to evaluate, do a physical inspection to look at the evaporator fan blades. If the blower is dirty, I need to have it cleaned and removed. If the coil is dirty, I need to clean it. And once I clean it, I need to replace those items and check the performance. All right, test in, test out is the best practices for residential tune-ups. I also need to clean the drain pan and make sure it's free of any obstructions. All right. Now, um, there are fins. I'll show you the fins here in a picture. Sometimes those radiator fins can be bent, and I'll show you what we're talking about there. All right. When you see stuff like this, just notice anytime a condensing unit or evaporator coil, if it's fouled and it can't reject heat, that's going to increase the operating temperatures and pressures. And just imagine that's causing me to use more kWh to do the same job. So I want to make sure these are free and clear. The fins that I was referring to, see these fins right here? They're kind of small to see, but notice how they're straight and vertical. All right, they have a certain fin per inch space that they come. If the outdoor unit or indoor unit, anything with fins, if it receives some type of impact and those fins are turned or they collapse, that also acts as a restriction and can increase the operating temperature and pressure of your system. Therefore, you can have some issues. So as a result, air conditioner technicians have a fin comb or brush that they use to open up those fans so that the air conditioner can receive appropriate amounts of air. We also have this coolant line. This is insulated for a reason. This is the suction line bringing the refrigerant that was used to absorb the heat in the space back to the compressor. All right, we want to have an efficient system, so we want to absorb all the heat in the house and none of the heat from the outside ambient because we just want to cool off what we picked up from the house. We don't want to cool off what we picked up from outside. All right, so heat travels to cold, hot ambient air is going to flow into and influence this temperature inside this pipe here because it's not insulated, and as a result, the air conditioner temperature and pressures are going to increase. I'm going to need more kilowatt per hour to do the same amount of work. Right, that's insulating the coolant line. All right, in summary, we talked about a few different things. We noticed how high efficiency equipment alone does not guarantee high performance, and that if we have an improper size, improper airflow, improper refrigerant charge, and proper duct system, that can all impact the air conditioning system. Best things to do is to reduce your load first through things like air sealing, insulation, and solar control, and then verify the performance by testing and testing out to get lasting results. And with that, we'll take some questions.
Brynn, that was amazing. I didn't think I would be taking so many notes just for myself too, so thank you. And thank you for teaching us the secret handshake. We did get a couple from the chat, and those who are in attendance, please feel free to keep submitting those. We'll wrap up Brynn's time with questions here. First question is from Michael, a little specific. He says, we have a nest with a geothermal and solar system. Do you have any tips on navigating this? It's a very manual system with a geothermal, as the nest does not have a setting for this.
That's pretty specific. I'll need to get some more context just for uh, the group here. I'm going to put my email in the chat, and I'd love to get more information about that.
Awesome. Cool. Yeah, Michael, please feel free to follow up with Brynn. Okay, some other questions from Peter. He said, please ask Brynn to talk about the short cycling of heat and AC equipment versus allowable temperature swing for healthy and fit people. He says, I set my allowance to swing up or down 1.5 degrees, no problem so far. What is too much swing if he's comfortable enough?
That's a good question. There's two ways to look at this. When we design systems for a typical residence, we according to Manual J, you want each and every room to be within 3 degrees of each other. So that's one key metric that we're looking for. As far as tolerances on your system, that really depends more on your equipment. The the better equipment, the two-stage and the modulating equipment will maintain the thermostat set points a lot more accurately, and they run the system longer to prevent short cycling. When the systems do shut off, they have the ability to overshoot, and they can cause the customer to react by turning on the thermostat. So it does have something to do with metabolic rate and also the physical characteristics of the person, but it can also be improved by the type of system that you're using also.
Awesome. Thank you. And then we had one more from Peter. He asks, are pressure gauges sufficient to determine proper charge of refrigeration equipment, or is some other tool needed for best performance?
Very good question. So pressure gauges are not enough alone to do it. You need to record not only pressures, temperatures, and you need to get variables such as superheating, subcooling. All those parameters together give you the true, accurate determination of charge, and pressures alone won't do that for you.
Okay. That's for you, Peter. Great. Question from Shri. What are your thoughts on DIY heat pumps? Since they come with set tubing length, would they be more accurately charged?
Not necessarily. That kind of depends on, um, like was mentioned in the onset, the charge needs to be trimmed. So it just kind of depends on if the DIY weekend warrior adhered to the installation instructions. If they don't know the ins and outs, especially proper charging, how to verify a proper charge, they could be in a situation where they either overcharge or undercharge the system. So I get that there's a market for that, but there's also it can be some pros and cons to that too. Another thing with the DIY, was it properly sized? And a lot of times when I see that, that is typically a no.
Okay, good to know. All right, a question from Michael. A little specific here. I have a huge April air dehumidifier in an exposed lower level basement because the previous tenant had a hot tub. Can I remove that, or is it still tied to the rest of the house HVAC?
I would need some more context for that. Feel free to email me, Michael. We can talk a little bit more about that.
That's awesome. Thank you. It is his email is in the chat, everyone, and then it will also be sent out in our follow-up email tomorrow morning. Um, okay, from Shri. Regarding window films, how are they aesthetically? Can they be an eyesore to neighbors across the street?
Very good question. The ones that we see, typically customers don't notice that they're there. There's some pretty awesome films that are applied, and the ones I've seen, customers were not really able to notice. Um, so I think there's some really good films out there that will do the job and also be pleasing to the customers.
Awesome. All right, currently I've got two more. If anyone has any last thoughts, go ahead and send them in the next minute or two. From Sue, she says, I live in Wisconsin. What are the best ways to find qualified providers of insulation and or HVAC upkeep that are aligned with energy efficiency rather than their own products they provide?
Better HVAC, the Better HVAC Alliance. They have it's a nonprofit that profiles high performance contractors, and they have to make certain attestments to do quality work. The commitments to educating customers. They have to be ethical in business, so that would be one great place to look at. It's also um, supported by Rewiring America, which has a lot of great energy efficiency and electrification guidance that's out there. So I will start there.
Awesome. And I know we've done some work with Focus on Energy as well, and they serve Wisconsin, so another great resource. Awesome. Okay. From Matthew, one big heat pump or a few littler ones? What
Mhm.
are the use cases for each? Any thoughts on air to water heat pumps?
Air to waters are awesome. It's a real specific application. Um, One big heat pump or smaller ones is called zoning. Zoning has some benefits. Like for example, in the Midwest, we may have the second floor hot syndrome, where your second floor may be significantly warmer than the downstairs. And typically, the reason why that's the case is that if it's one, let's say, furnace or heat pump combination, that furnace and heat pump is trying to manage a whole house, and the thermostat is typically located on the first floor. So, an excellent way to offset that will be to zone or put a second heat pump to service the upstairs. Has some really great benefits, including comfort and also energy savings. You're only going to be operating the system as it's needed. Quite often, customers have the tendency to overcompensate the lower level to get some comfort on the second floor, which is, driving your utility costs the opposite way. So, excellent question.
Awesome. All right, I'm gonna list off two more questions. Bryn, you're really kicking it off here really well. So I'll share a compliment before I read the last two. Peter says Bryn really knows this stuff and he can teach. So please
Oh,
enjoy that
thank you, Peter.
compliment. All right, the last two I'll read off, and then any other questions that come in after this, folks, I will connect you with Bryn. Um, from Cecil, why do some manufacturers say not to or rarely clean condenser coils?
So I don't know if I agree with um, that remark. A lot of manufacturers that we work with, they preach best practices, which involves cleaning a condenser. If you don't, oftentimes you can void the warranty. So maybe if you follow with me in the email, if you could point me in a specific direction where you might have seen that, I can probably give you some context. But I'm not sure I see that commonly.
Great. Great to hear. Awesome. And then last question I've got for you right now is from Jim. Does using a ceiling fan improve AC efficiency?
It doesn't improve AC efficiency, but it can improve comfort. Warm air tends to rise and cause a stratification. And if you're able to get your ceiling fan, oftentimes if you turn it in a reverse direction, if I can pull that hot air mass down and blend the room, I can make it more comfortable. So, um, from a standpoint, if you're more comfortable, it may prevent you from reacting by changing the thermostat to make it cooler to get comfort. So, efficiency, no. Comfort, yes. Energy consumption, yes.
Amazing. You've had an answer for everything. I don't know how you do it. Do you have any final thoughts before we kick this over to Kenzie, Bryn?
No, thank you all, MREA, for allowing me to do this. Your organization is awesome. It was fun to hang out with you this evening.
Back at you. Yeah, thanks for this master class. Awesome. Well, folks, again, we'll get you connected with Bryn. Bryn, feel free to stay the rest of the time if you'd like. And Kenzie is the MREA's Research and Grants Manager, and she's going to talk to you a little bit about a program that actually Bryn plays a part in. Kenzie, take it away.
Yeah, thanks for the introduction, Celia. Let me quick share my screen here. All right. Can you see my screen all right?
It is not the full page right now, though we can see it.
How about there?
Yeah, great.
All right, sweet. So I'm going to talk just a little bit about the Energy Coach Training Program. It's a new online course and program that the MREA is coming with very shortly. And to kind of just start with the purpose of this program. So obviously, reliable and affordable energy matters to all of us. I don't think we would be here if that was not the case. We care about having low utility bills, about making sure our homes are comfortable, that there's not emissions or harmful pollutants inside our homes, um, and making decisions about how you use and consume energy in your home and in your life can really influence how that impacts the world. But at the same time, navigating a lot of home energy improvements or decisions can be very overwhelming. They can be confusing. There's a lot of information out there. Oftentimes, people will be wondering what kind of upgrades will have the biggest impact for me. What should I do first? If someone's going to need to upgrade their HVAC system, do they need to first enhance or increase the amount of insulation they have? There's questions about what might make the most sense for my home. Are there available rebates or opportunities out there to help me be able to afford these sorts of upgrades? How do I choose a quality contractor that I know will do a good installation for my home? There's a lot of factors that go into these decisions. Our program aims to make these decisions more simple. Energy coaches are individuals that are trained up to deliver whole home guidance to Wisconsinites that are trying to figure this kind of thing out and that are looking to make energy improvements in their homes, looking to be more energy efficient, to electrify, to reduce their emissions, and any of those sorts of things. So, energy coaches can work with you to help sort of translate all these technical concepts and industry jargon into plain language that you can understand and use and take action from. They can answer questions you have, help compare options, talk through decisions. They can help you figure out what kind of contractor you want to be working with to navigate different rebates or incentive offerings that are out there. Energy coaches also create a tailored home energy upgrade roadmap for you. They really place the individual at the center of the whole thing and provide personalized guidance that is based on your goals and your home, your budget, and your interests, and really help you take the right steps with confidence. how this program works for folks that are looking to work with an energy coach. You just start out by providing a little bit of information about yourself and your home. You'll receive some additional information about how to start thinking about these sorts of concepts and tools you can use along the way. Then you can pick an energy coach to get connected with. You can meet with them in person, virtually, over the phone, uh, ask your questions, talk through what you're hoping to do, get help making those decisions. And then an energy coach can work with you to create that customized roadmap that provides some estimated costs, what resources are out there to help you move forward with those upgrades, and to really help you along the way to move you from a recommendation to an action. And then, like I said before, support along the way. So finding contractors, troubleshooting issues, post upgrade, are you happy with what is being installed in your home? Is it working for you? And sharing those stories. So that's the portion of it for folks that are looking to work with an energy coach or get help from an energy coach. But let's talk about who these coaches are. So, Energy Coaching 101, that's the online course that we're developing right now. It's going to be offered free, asynchronous, and it's taught by half a dozen industry professionals with lengthy experience. Brynn is one of our instructors for a module on HVAC technologies and does an excellent job, as I'm sure you all have seen throughout this webinar today, but several other amazing and very well educated folks teaching that course as well. The coursework itself covers a whole variety of issues, really the whole home approach. So everything from building science, insulation and air sealing, to your HVAC systems, the other appliances and lighting and things that use energy in your home, your car, if you're interested in solar or battery storage or other renewable energy options. And then moving those sorts of technologies and home energy systems into action. So financing to move projects forward, finding contractors, making sure consumers are protected and not being scammed necessarily by certain contractors, and then also training on coaching in practice. So things like myth busting, building trust, building those communication skills, and really working to help people on an individual level. After the training is over, coaches will continue to receive resources and get help through these very Wisconsin-specific tools and templates. We have a bunch of resource guides for coaches, contractor networks, and then just ongoing support from the MREA and our partners, and through this trained cohort of energy coaches across the state. So, if any of you are interested in energy coaching, whether that's working with an energy coach to ask them questions or get some assistance, or maybe you're interested in becoming a coach yourself and helping people navigate these options, you can feel free to reach out to me. I put my email in here, or we've got this QR code here that will take you to an interest form. Currently, we are finishing up the development of this course. It's expected to launch within the next month. So by signing up for that interest form, you're just letting us know that you'd like to be notified once it's live. And that is all I've got. So if anyone has questions, feel free to drop them in the chat or reach out to my email, and I'll pass it back to you, Celia.
Amazing. Yeah, please feel free to drop any final questions about energy coaching. I did also put Kenzie's email along with many other places you can contact about today's presentation or future webinars. Feel free to reach out, and I'm not seeing questions come in immediately, so I think I will let everyone go off and enjoy hopefully what's a sunny afternoon on their end. Thank you so much to Kenzie and Brynn for presenting. We greatly appreciate it. I'm